agent which has brain, along with it has access to tools. Tools will be our hands and all. So what is this? An autonomous agent which will use eyes in case of this multimodal medical, understand. The second one being memory plus the hospital management tools, which I have embedded in this particular file only, or the agent file. Now the fourth one, we already talked about the power of agentic AI, Gen AI and stuff. What about fairness? The conscience of it. Can we treat AI in such a way that it is fair to all? In this case, let's say that AI can differentiate or not based on patient intaking, based on color of a person. We all know India has diverse set of people. Some are white colored, some are black colored, some are brown, and we have a range of it. So does kind of AI or model has bias in it. So that particular thing we will see in it. Now, the fifth one, this I call safety and guardrails. The safety net sort of. Why? Because real horror stories of AI gone wrong or AI gone rogue, you can also say, is quite prevalent in the market. Guardrails we have to build here. What guardrails? Guardrails that block dangerous outputs. Regulatory landscape. Many of you might have heard about from jailbreaking. That is why we need guardrails in place, safety nets in place, and stuff like that. Do you know, like India recently, we had previous workshop, and after that, if you think, India recently released a framework called SAHI framework. What is it? Government released guardrails or framework for medical domain. If you specifically see healthcare AI strategy, India launched in 2026 itself for Indian. So these are also related to guardrails specifically. Now, going ahead, everything in this particular workshop is live running, either API, or we will see something interesting. We can, instead of just from the API, which is definitely models hosted on cloud providers, in this case Gemini, we can use even the local LLMs. You remember previous time I had showed you, let me open the terminal and I can show. So Ollama, we had already installed. See, we have this much models this time already installed in the Ollama. So we will see local models also. Now, let's go to the first one, start of the workshop, basically our journey. So if you see on top itself, it's written backend. How many backends are there? Three. So we have three different backends configured. Google Cloud, the Gemini thing, and then the Ollama one, in which we are using MedGemma. So do we have access to chat so that anyone can reply and we can check? Can anyone confirm that anyone can chat and text here or not, so that I can interact basically?
No, sir.
No, Mansi, you said, or yes, not understood.
No, sir, it is not available.
Okay, so then kind of I hope you guys are following, and if any coding question or anything you have, you can send me through feedback form. I will try to get the answer of it, or let's say any issues like that. So in this one, if you see, the backend is mentioned. As I said, local Ollama we will be using for model serving and stuff. Demo is kind of pre-recorded one. Let's say my GPU fails, API fails, then I have already embedded some part of it, that how the response should come. That's why demo sort of pre-recorded that for many cases it worked, and how it works, that is in pre-recorded. So if you see, demo outputs are already pre-recorded for our demo cases, but that's not the main thing. Now, here's a question. When a doctor looks at patient, do they just read the text? Do they just ask the patient that what are your symptom and give them medicine? No, they do a lot of tests nowadays. Let's see, X-ray test, ECG test, and various lab reports. Here, the patient describes, if I will go below, the patient will describe its symptoms. I have already built symptom for a patient. See, patient case. So the patient has name, Ramesh, age, and all. He had some symptoms like crushing chest pain, radiating to the left. So all related to medical domain. What are the vitals? As I said, along with lab reports, what we have, other sort of reports like vitals, check what is the history of the patient. But these are all textual information. You can say the information which is properly captured in text. But doctors also analyze images. and multi types of data basically. And that's why we have built is multimodal basically AI. And that's why even the name is multimodal medical AI. Now, which particular model we are using as of now? So Gemini 2.5 Flash is a latest model, not too much latest because currently Gemini 3 and ahead is there. But 2.5 is a multi-model which is kind of fast also and good in image analysis and all sort of. Gemini 2.5 can see images and text at the same time. So let me show you one thing. First, we will give only text to the patient. Let me run this particular file. So we see we have first model. The virtual environment is already activated. As we can see, workshop 3 is mentioned on top. Let me clear the terminal. Now, we will run the first one. And what we saw is kind of the first one ran and demo mode happened. Now, why demo mode happened? Because Gemini API key failed, failing to demo. And that might be when I had, and that might be key issue because in the free, if you will see Gemini API, let me go to my API and see. So this is key. I hope this is added in the environment variable. We will just check. So I will later delete this particular key. Yeah, this is properly added and Gemini is there in the backend side. I will again try to run it and see. Okay, I hope I'm in correct folder. Yeah, this also is the same folder in which I have added. Yeah, let me again run the same and see does demo mode only happen or no. It seems demo mode only ran, might be API issues and stuff. Gemini failing to demo, Gemini API key is not working. Now I will do, as I said, interesting one. API failed, we have another method, local method. I will change in the our environment file, basically configuration of this particular one. And let's see by running now on the configuration of, sorry, Ollama. And this also so now Ollama gave us a response. So see which one version ran now, Ollama local, and which model we are using, medgemma. Now there is an interesting thing why we are using Quen 3, we will look into it. But for vision and text, small text, we are using medgemma 1.54 billion one. And if any of you have heard of Gemma series, Gemma is kind of the Google's open source model series. So if you will just search Gemma, then all the models which are open source and released by Google will come. Now Google has fine tuned this model or specifically trained a model for medical use case, which is that is medgemma. And if you will see, medgemma has a lot of applications like high dimensionality medical imaging, longitudinal medical imaging, and others. There are some demos also application built. We can try the demo. So this is a electronic health record navigational agent they have built. We will later look at this. Let's go back to our case. So in this case also we are using medgemma. Now first is that let me show you that first approach. What happened is, there will be approach one. Yeah, what happened, we only sent text to the Ollama or medgemma model. So what is the code of it? So let me show you the approach one, which is below. Hmm. Approach one. See what is happening is that. So these are print statement which you just saw here. Approach one sending text only, and we had a text. You are a medical AI assistant based on these symptoms provide and are specific to it. Patient ID, we took the Ramesh ID which we had defined earlier, and then we got the call. So since Gemma kind of failed because of whichever reason, what we did is that we this call Gemini also calls the Ollama one, because in the function I had kept it Ollama, that if the backend is uh, Ollama, then it should use the Ollama model. So in this case, it will be Gemma. So approach one again. Yeah. So we got the response. If you see what was the response, response was most likely diagnosis of the person is this, and stuff like that. If let's see one thing, demo, let's go to the demo text. Hmm. So yeah, so this is the kind of first demo output of the first one, which would have happened in the demo one. But if you see here, it's completely different. text only live from which came is the current medical history. Now second was approach to image analysis. But remember one thing, if you will go to approach to, our image is kind of a sample chest x-ray, which is a funny image, means a person laughing image sort of. So let's go here and try approach to. Yeah, here is the approach to. So this is image analysis. Now we convert the image into image bytes using various thing, and then we sort of do on the image. Now, if you will let me go and show you the output which came. Output came was the chest X-ray is unmarkable, the bone structure is unmarkable, the catastrophic angles are sharply bilaterally. There is no evidence because we had told the model to behave as you are a radiologist and analyze this X-ray image. So we had already told it that this is a X-ray image, although this is not. But since we had told it, so what it did, it tried to find in it the bone structures, the overall impressions, and it could not remark regarding anything. That's why it is saying unremarkable, because there is no evidence sort of anything and any unremarkable thing in that particular image. Now let me do one thing just for the sake of understanding. I will do and completely change the prompt of it. So if you see prompt here is this one, and I will just cut it and I will let what are you, what is visible in this image, because that was it, laughing image. So let's see what happens. So I will run this again. See, now the text generation is happening. This will be sort of little bit different, and we got the text image. See what the response came. The image shows a person with dark curly hair smiling broadly. They are wearing a yellow shirt and appears to be looking. Exactly description of what this image was, because this was not an X-ray report. So now that's why, because we had told it initially to behave like a radiologist, it behaved in such a way and gave us that particular thing. Now, if you remember, the output was that there is no sort of markable approach. The bony structures are unremarkable and stuff. Let's clear it, and we will do one thing. This X-ray image is of real disease, a person with sort of a disease visible in it. I will now change this particular image to the name which we have already embedded in our code, and now again we will run this, the version 1. See, this is the real analysis of medical image which is just happening, and already we got the output. What is the output? It is, it says it's possibly a bone structures. See, overall impression we got here. Okay, let me go. Overall impression, right lower lobe opacity. So in this particular image, it found right lower lobe opacity. So whatever it found, heart size is normal. The cardiac silhouette is unremarkable. Right lung field shows a focal opacity in the right lower lobe. Left lung field is clear. So catastrophic angles are bilaterally. Bone structures are unremarkable, means bone structure is fine, and it came up with all the approaches and everything. So based on the image, text, and vitals means these particular analysis and all, we have approach 3. What is approach 3? We gave everything, the X-ray analysis, the symptom and everything third in the approach 3rd. If we will go below, we have approach 3, full model, multimodal analysis, image plus vitals and lab. And we told it what is the prompt. If you see prompt, you are a senior emergency physician, AI assistant performing a comprehensive multimodal assessment. It has chest X-ray, which was the same image, clinical presentation, patient details and everything. What was the response? The response was quite comprehensive one. What is finding? X-ray, right lower lobe opacity, whatever it was, clinical 50 Ramesh, whatever his vitals were and everything, assessment it did, and urgency high. This patient is hemodynamically unstable, hypotension, hypoxia, and has evidence of myocardial injury. If you see, it has already suggested immediate action and things like that. Confidence level, why. Now below that, this is our part, why multimodal analysis matters, because in text only approach, image only approach, what is the problem? symptoms only text, you will see moderate accuracy or confidence, or expert system if you have heard in the past where like text only. Now image only model happens is that you have classification sort of, that this image has which particular disease chances, but no report sort of, or no suggestions, or if you see we have actions, urgency, many things like that analyze. So that's why we need multimodality. And one interesting thing, we are doing all of these things locally, none sort of AI of internet and stuff. We are analyzing everything, model is in local. For example, I can do for showcasing same completely. Okay, do you know why Gemini API was not working? See, I had not uncommented the API key, and that's why it was failing. If you remember, it was not a API rate issue as per me. So now what I will do, I will show you with the Gemini also. Let's do it. And I just uncommented it that time, not focus. I missed it. Ah, cleared. Now I have changed the backend mode also to the Gemini, and see, we have a output that now Gemini 2.5 Flash Cloud API we are using, and we can notice this also in our API here. If I will check my usage, say till before now no data is available, but now API calls are happening. And for example, uh, text, because this is Gemini, so this has given completely different information. And medical urgency level, it has also came up with its own markdown sort of answer. And we will have sort of report. So this was it, text markdown on without image. This is based on the image. So cardiac syllability appears within normal limit. That's what our model has also told, that heart is in normal limit. And overall just we might have final report. Yeah, so urgency and stuff, we have complete urgency classification, extreme emergency, code red. Our model has also said high emergency. So if you see, Gemini API now got called, and if I will refresh, one data should come, which will be just now call of our yeah, if you see, just now call happened from the Gemini API, and that's why we have the second one. And we had already seen the demo one which was running in case of Gemini API failing. So that's now we are going to unique section. What is that? We already did the first one, multimodal one. Now we are going to a kind of thing, just like in this one we told about the Ramesh in 3-4 line. If you will go to the Ramesh patient information, where was it written? Okay, I will have to search Ramesh. Patient case. So name, symptoms, and everything we had written in 4-5. But let's say your patient, you are a patient which has plethora of document about your medical history, about your disease, and many things like that. For that, you need a system which can query based on requirement and stuff like that, and then build a sort of comprehensive report of that particular system. Now, I asked one chat GPT a kind of question. Let's say, can cinnamon cure type 2 diabetes, or let's say my hair fall? And it said yes with confidence. Why? Because it thought on the general perspective. And what happened basically in this particular, if I asked regarding hair fall or let's say the type 2 diabetes, I told it just based on the internet trained data, it quoted you a particular stats that how much relevant that is. That is not relevant exactly to me. I might have allergy with cinnamon, or I might have allergy with a particular chemical for my hair fall, and that's why I'm again quoting you what RAG is. Retrieval augmented generation comes in. Instead of generating answer from memory like the foundation models weight, what it does, the AI first retrieves from the information or database which we have stored in our database, vector DB basically, then generates an answer with citations, just like many of you might have used the, let's say, just to do any Sahi framework we had done. What is this? This is quotation or citation of the information source. So just like this, if we will have citation based on which it is quoting report or quoting about you, that will be kind of RAG. Just like a student, let's say you, if you give, create a report or create a article or research report, you always cite from where you got a particular information or biased or stuff like that. So that is it. Now, what happens is that when we are loading real medical guidelines, so there are various frameworks for the guidelines, like AHA is the one, WHO, ADA, NICE. Let me show you. So there are very, okay, I had already included some guidelines here. Just let's go below. See, medical articles. So ADA guideline, WHO, CDC, there are various guidelines for it. Type 2 diabetes management guidelines. Just I was talking about the type 2 diabetes, right? Which we will be seeing in this particular case. So we have American Diabetes Association's content or medical articles based on it, and we have a kind of knowledge created on it. Means this is kind of our medical article. What we will do, we will create vector databases on top of those medical articles, store vector databases, and then we will retrieve from the vector databases based on our query. Query is what? The question we ask. Okay. So what is the, let's say that we have a question. I had in the creation, I had used a question, what is STEI, STEMI heart attack. So this is kind of a question like what are the first line medication of STEMI heart attack. There were other questions. Yeah, this you see STEMI, this is database regarding it, and we will have another question also. Yeah, so this is the only question, okay, I had kept. Now here's the one particular thing. Let me do one thing, is that run this particular file. Let's clear, and we will see again the multiple approaches. Multiple approaches means what? A full RAG pipeline, demo 2, and if you demo without RAG, means without the patient history or any sort of information like that. Let's run this particular go to. One thing you might have noticed that it's difficult. Why we always use notebook while tutorials and while works and stuff? Because it's very easy to follow cell by cell. Now here we are trying to be in the production sort of environment. Same thing, we are this time using Gemini 2.5 Flash. Why? Because I never changed this one to Ollama. Now Gemini Flash, it got initiated. We are building ChromaDB vector database. TF-IDF is a old retrieval sort of, where we calculate the importance of information or document uh, based on this particular vectorization technique. So we are not using that particular vector database or vectorization sort of similarity mechanism. Here we will be using ChromaDB, and for embeddings creation we are using sentence transformer. Bag of word is a old one in NLP technique which we are not using. Sentence transformer came, so there is a specific model in the sentence transformer which is All-Mini LM-L6 V2. This is kind of 90 MB file which if you will load locally it will help you. Now going below, if you see once semantic retrieval demo, the first one we directly asked it, what are the latest guidelines for mapping type 2 diabetes, and we had created the embeddings vector db ChromaDB. And what happened? Semantic retrieval demo we are showcasing that based on the query, the database, these particular information, the query happened. What is our database? So vector db we have created for these particular information. So if you see for this particular question, what are the latest guidelines we have for most non-pregnant adults with type 2 diabetes? This was the preview sort of document, and we can see this metadata is coming from which one. We will have sort of the first one, and question was what? Question was latest guideline for managing type 2 diabetes, because this was related to type 2 diabetes. Now this is related to hypertension. So the question, next question, where the next question? Yeah, what should sepsis be treated in the first hour? Now this is related to sepsis. Now the confidence score of sepsis is CDC1. So CDC1 is sepsis. The instead of the first one and second one, sepsis already got the confidence, the third one, which was the article first one. So similarly, this is kind of a retrieval I am showcasing you how we do semantic search from the vector DB based on our query. Now query happened and we got relevant document along with citation, like this is document number 1, 2 and stuff like that. Now is our main RAG pipeline. Retrieval already done. Augmentation is adding it into the prompt and then happening. So without RAG, I had told you, right, that if I will ask without RAG, what will happen? It will give me general information based out of internet. So as an AI, so see what interestingly, because Gemini 2.5 Flash has Google's Guardrails, so it is already saying initially itself as an AI cannot provide medical advice, diagnosis, or this disclaimer sort of. Now then, What was our question? Question was diabetes treatment without medical sources. Question was here. Oh, what are the first line medication for treating a STEMI heart attack? So, what managing type 2 diabetes is highly individualized. Wait, question was okay. However, I can consider general symptom of type 2. So since I think it not understood completely the context, so it is giving no sources may contain inaccuracies because it is coming, the information is coming out of the foundation model and not citing a particular information. Now the RAG source based, as we said now, first demo without sources, which has many chances of hallucination, and that's why we kind of ground our application or AI Gen AI application with RAG pipeline or tool with memory, we can say, and stuff like that. Knowledge source basically. So what is the RAG architecture production based? So just now we had a document, we had kept document as these ones also. So medical articles basically. We create sentence transformer, embedding model, store in vector DB. Then we have a query. From the query, we get top K results. We already have seen that these are the top K results for each query. Sorry. So, and then we have, we give the top K results along with our main purpose to Gemini in this case, but I will show you without Gemini also. I will change it to local Ollama, and user queries augmented with the result, and then we send it, cited answer sort of. So now the key moment. What is this key moment? With RAG. With RAG, grounded, cited sort of information. See, method 2 kit. Okay, method 2 was this one. What is the production upgrades? Just give me no source with RAG. Okay, is not met. Okay, this with RAG was this one, and if you see without RAG was this one. This gives so long information based on its information. With RAG, it cited ADA standard of care 2024, which was this one, ADA standard 2024, and it said the first line of treatment for type 2 diabetes is metformin unless it's contain contra indicated. So it's kind of a, with RAG we have a clear structure to it, and that's why you can see in our prompt also what role and stuff we had given it. So safe prompt based on the following medical sources, answer to the question, source for the this. Okay, this is a demo one. Let's go to the real prompt. Just a second. So document retrieval here happens. Hallucination demo had real prompt also, I think. So dangerous prompt is basically without sort of any citation. So since we were not in demo mode, this is the kind of our prompt. What was the prompt? According to ADA, first line of therapy, and this else without track. We are calling it here. The content of dangerous and safe prompt, we are calling it the Gemini one. Now I will show you the Ollama one. Basically the same thing. This is kind of my printed a statement that what we understood, that we have vector embeddings, which is kind of a meaning of the document. Whatever we create embedding, ChromaDB is for vector DB storage, then LLM generates. Now I will do one thing, clear this one and change our model to, instead of Gemini, we will do local wise. And I can prove also that I will comment out the Gemini API key. And still this will work, and this will be different sort of output, and speed might be slow. Why? Because it will be happening. Let me show you one interesting thing, that as soon as I will hit enter, my processor means GPU will have spike in its usage. As you can see, currently it is 0 used. Why? Because we are not loading any model or doing anything. Everything is done this visual by the internal GPU. And now I will hit the second one, and the local models will get loaded. Okay, I just, what happened? See, Ollama one this time it is running. Why? We have disabled our that thing, Gemini API, and you see here the suddenly GPU spike has started happening, 6%, 58%, 92%. Why it's happening? Because currently our local LLM is getting used, and you see our information already without citation this time came, which we were calling basically hallucination mode, which is there. Metformin is typically the first line of medication. This is the exercise, more monitoring, no source may contain inaccuracies. Why? Because this was without track. Now below one, based on our particular articles and stuff, we have. So we have source. What is the source of this particular one? ADA standard of care. So we got a particular reply, and since our this particular call happened, so you see my GPU usage dropped completely to 2% and stuff like that. In middle we had spike because local LLM we were using for this particular one. Now, since can we take any question anyway, Mansvi? If anyone has any question, they can perhaps unmute and ask, because this was our second one, second use case, which was related to medical rag frontier. So if we remember our topic, first was symptoms plus medical images, which we already saw. That symptom kind of we sent in text format, medical images we parsed it, and for this I have used a model, open source model actually, Medgema. This is open source model. You all can download from the Hugging Face and try with it. So let me show you. Okay, there will be yeah. So Mansavi, can I, does everyone has access to unmute themselves if they have any question or anything to ask before we move on ahead?
Yes, sir, they can unmute.
Okay, great. So anyone, if you have any question before we move ahead to sort of main component of our session, you can ask anything, like from workshop one also you can ask two, or let's say this one, any doubt and anything you have. Okay, let's just wait for a few minutes, then we will then jump to module 3. I can even search for till, let's say anyone has SAMPA X-ray with, let's say, whatever CR system outline. Let's search anything. And I will, okay, I don't know what is pleural effusion, but it seems that hemoglobin opacity typically is sharp. And let's say I will just open this image. I will save it. Mm, let's directly save to our folder. Okay. Not here. Let's go to the. I will keep as of now. Okay. Let's first rename this one to. If anyone has any question related to this medical and how this model or anything, you can go ahead and ask before we start the next part of it. I renamed this one and kept it this. Yeah, the chest got. And we already know that this one has massive pleural effusion. So let's see our model is able to local model basically, because we have disabled the Gemini, can figure out this or not. Python 01. You will again see the spike in my GPU because this is again image analysis is happening. You can see 52%, 100%. See, interesting one. Overall impression, complete opacification of the right hemithorax consistent with the large right pleural effusion. It had no context basically. I just took any particular image from the internet of a particular disease related and which can be detected in X-ray of the lungs, and we have our model already saying it. So a small left pleural effusion, clear left lung. Now for this particular Ramesh only it is going because we have not changed the patient. So whole analysis approach 3 it is giving that right hemithorax is opacified consistent with large. So and this particular model's accuracy is also kind of good. So you just saw how and this was even not without rag, like just image along with very little context. We can do the same with any particular disease. I don't know, X-ray with the fracture, let's, okay, X-ray with fracture, it should also. So because time we had seen the lungs one, let's see. Okay, this one has common mental line fracture. Let's see, because here I think is the fracture. Let's see, this can work or not. This will be unique use case because this is not even the lungs. So I will do, okay, this one is getting saved in WebP format. I will have to convert it first. Okay, let's save it, then we will convert it later. Let me do one thing. Does anyone has question before we move on to? Okay, I think one, so we can move ahead right to next one. This the one I will just now show you that how even the hand sample will work properly. And I have done basically nothing. Thing I meant to say, let's save it as, I will replace ENG. I want to convert it right. So I will replace the chest one and we will see what analysis comes because this one has fracture. I don't know, means internet, this data says that, okay, most commonly misdiagnosed fracture. I don't know. Let's see, because I'm not medical professional, but still see, I'm able to act as somewhat as a medical professional, analyze the X-ray report without even a doctor and with a kind of fine accuracy, true be told. And with outputs means okay, I had already told it to be heart size, lung size. So I will have to completely, X-ray is unremarkable. So I will have to completely change it because I remember in the prompt I had told it to be radiologist. Let's go to the prompt, which was image approach, and you are a radiologist. See, now I will change it to analyze this chest X-ray radiologist. Okay, heart. Okay, I had given it completely bone structure, catastrophic angles. I will just remove completely and I will tell it you are analyzing chest. Chest, I think somewhere else is also written. So I'm just taking the autocomplete given by GitHub Copilot and I have replaced the chest because this is not a chest one. And let's see what the finding it gives. This will be sort of interesting way of what it gives as answer. Okay, what happened? Ah, I did some coding mistake. Let's go. Ah, now running again. This time, let's see what we get in the text only. See, interesting one. What is it? Acute, acute coronary syndrome. What else? Vital signs, blood pressure. This. Okay, image to process it. The image. Sorry. Here is the approach to analysis. The image shows a left hand X-ray. It properly recognize it. I don't know which hand it is. Let's see again. Okay, this is left hand. So see the visualized bone appear intact, no obvious fracture, dislocation identified, the soft tissues are unmarkable. So I'm not sure that this was a fractured image or not. So I will have to go to article to read it. Was that even if a fracture diagnosed as a stain or a sprain? So there are many ways. They have not given. There are many ways hospital could have missed a fracture. Some common example. Okay, I think they have given a sample where people miss a fracture. That's why we not got sort of fracture detected. But this time, okay, although this is taking, let's, for one case we will do, and then we will move ahead as fast as we can. That article was Uranus to be true. Okay, this is foot. I want different one, at least which is, because everyone has an arrow in it. I'm looking for clean one where they are, perhaps anatomic procedure. I'm not sure. Ah, okay, this is so obvious. Perhaps this one. I'm not sure. Fracture radiology reference. Okay, it seems I should read it, otherwise it might happen. Ah, these are fracture images. Okay, this one is case 3 pilon fracture. We will take that image. Let's save it. Okay, this one is getting downloaded in JPEG. I will convert it back later. I will reply. Okay, no. PNG. Because we have already referenced that particular name. That's why we are doing sort of this converge. Now let's see that it is able to detect fracture in it or not. The same fracture which we had seen on the website. What was that? Pylon fracture. Let's see. Image analysis happening. And this is local model one. Hmm. The image shows a lateral view of the left ankle and foot. There is a fixation device present, likely an intermedullary rod and screws extending from this. There is a prior surgery at ankle. So this patient has gone through previous uh, sort of operation and stuff. That's why it is saying post-operative change of the left ankle with fixation device in place, no acute finding. So already device is there and stuff. I'm not sure about the medical terminology, but those of you who are from medical domain perhaps might have understood the image that what particular fracture it is showcasing, and there is perhaps a device or this AI has detected wrongly. That is also possible. So in that case, we can do is we can change our environment to Gemini. Let's go with Gemini once, see what Gemini response comes. Gemini response, we will see. And here is our Gemini. Okay, this will be fast because Gemini should analyze image fast and then we should be able to get it. Okay, it gave so long test that we will now have image analysis. Hmm. Okay, see, Gemini 2.5 was exactly able to detect the pylon fracture of the distal tibia with associated, despite the presence of internal, and it has also detected that internal fixation wires are there. So this suggests a complex injury, recurring urgent orthopedic evaluation. It has detected all sort of things. Now, the real part. I think we had enough of the RAG and the multimodal part, which we both enjoyed. Let's again go back. Okay, let's keep it Gemini as of now because I know agentic part is two model tools calling, so possibly my Gemini API will hit for sure. Now, the main centerpiece of our today's presentation. What is that? This is this one. Forget chatbot, forget autocomplete. What you are about to see here is AI that reasons. It looks at a situation, in this case, the medical situation, decides what to do, takes action. Agentic, as you have heard. And I might have previously also told about what is agentic in previous work, previous this workshop. So what is agentic? When we give a task to a particular agent and the agent performs it, and we give it gives us output. Sometimes asks us question if we are needed in between. That is called human in the loop. So it takes action basically and decide also what to take next step and everything like that. So that's why it is written this is real agentic. LLM autonomously decides which tool to call in what order, what are the arguments of the tool is the basically Python function which we create in this particular case, and we kind of chain multiple tool means one after another. One change one tool's output is kind of an input for the another tool, that sort of setup. Now let's do one particular thing. In this particular one, we have a scenario at our hand that we have simulated a scenario. Okay, we are at correct one, right? Yeah. So medical articles are already there, which is for what? RAG. So this is kind of a combination of module 1, module 2, finally coming into. You will see one more thing that we are using both modules, multimodal along with health articles for knowledge. So medical same as module 2, as you can also read it here. And then we have vector database, RAG, and so this is the main thing. What I was talking about just now is that we have a simulation of hospital. Here we have simulated ICU, 8 beds, ICU bed 1, 0. You remember in initially I had told that ICU operations we will see. So 8 beds, 7 in this case. If we will see ahead, let's close it. So condition of it, 7 beds are already occupied. Look at the severity bar. Priya is at 9 out of 10 in the severity of patient. How severity is for days, the person is it for one, what happened condition, and multi information are already there. Now, here comes an incoming patient. Like, so hospitals will always have some new patients coming, right? So in our case, Mira T, incoming patient. Now, what will happen? Once a new patient comes, and generally in the real world, what happens? The doctor or the operations team will check if there are available beds or not, and then allocate it. In this case, Mira T is coming with septic shock, where it is written. So condition STEMI, ST elevation leads to, and stuff like that. Labs, lactate, her vitals are these particular one. So Mira T, another patient is Arjun one. So what we will do is that, mm, let's go to our terminal and we will start with the agent execution. But before, okay, directly let's run 03 module, which is agent one. And I think I had removed the Gemini one, perhaps. No, it is still Gemini. So, okay, let's see. I will show you that why agent call it so expensive that my Gemini will suddenly hit a rate limit, perhaps. So currently it is happening. So emergency, you see, what is the architecture? So here also I have included a lot of information. What is the architecture? LLM brain, Gemini or Medjama. In this case, currently we have Gemini. Why? Because we have not removed from the workaround and we are using it. Automatically function calling happens. What are the functions we have created? So check bed availability, which checks that beds are available or not, get patient info, analyze patient x-ray, search medical knowledge. See, here vision is also coming into picture. Here text is also coming into picture. Here tools are also coming into picture. So a kind of a use multimodal AI also, plus RAG, and then plus tool call along with various things. So if you see, available tools are total. What is the function of each particular tool is written here. Send an alert to notification staff, used for notifying, means this is send alert notification, assign patient to bed. This will automatically do the agent will automatically assign a patient to bed, bed to a patient, and automatically discharge also if a patient is ready to kind of based on a particular report in a particular time and stuff. Current ICU status we already checked in our code. Here was the current ICU condition. Scenario 1, emergency STEMI admission. So incoming patient, Mira T, we just seen. And then what happened? Medical knowledge. Why? Because the model will be able to make more inferred and correct decision that how severe this situation is. That's why what is happening is that knowledge base vector RAG is getting called, and the model is getting loaded. I had told you about embedding model, this one that gets loaded. Ignore these warnings. This is just regarding the model loading. Now here comes the main part. Agent execution complete. So already Gemini would have failed, I think, or passed. I don't remember. I will have to check. Okay, here we don't have, perhaps API call not happened, or API call completed. We will just now see. So patient one, clinical, I have identified one bed available. So this is LLM responding. So patient was this one, agent final response bed availability it checked. Patient information condition is severe, indicated by STEMI, low blood pressure and stuff like that. We had passed it basically. And then alerting care team, it has to do these. So this is clinical reasoning, means it is thinking of these things. Now next step, what it has to do? Ensure a physical approval for bed assignment, this. Now how LLM calling works. So this is kind of an explanation of how things are happening. So we give hints, doc strings of all the tools which we have created. What are the tools here? And then the LLM has power to, we pass the function to the model as tools, and then LLM calls specifically that tool without any sort of extra text. So handle this STMI patient in this case and stuff like that. So many things happened. First, it checked the bed availability, then it checked the patient information, analyze patient X-ray. See, this is where our that particular thing came into the picture. So you see, interesting one thing. I had replaced the X-ray, our original X-ray as this one, where it went, the chest X-ray with this one. And what happened as a result? In the analysis, X-ray analysis, It is saying the provided chest X-ray was identified by multimodal as oblique radiography, right ankle. It is able to identify that this is right ankle, not the chest X-ray. So it might, it is an important to note the discrepancy that initial prompt treated a chest X-ray was available, but the analyzed image was of an ankle. Because in initial pipeline, I had told it I will give you sort of the real X-ray of chest, which we had named it here. Let's now do one thing. Take this one to fourth one and change this one to the main file. And now again, we will call the Gemini API. Let's see it works or not. So again, same things because this is coming from our static data. Scenario one, it is medical. Now this RAG is happening. That's why model got loaded and stuff like that. Now LLM calling will happen. We were seeing the X-ray. Now after that, medical bed search was there. We will just now see below as well. So it is what's the all autonomously tools to call, and tools call will happen just now. We will see. I hope I'm clear and you guys don't have. If you guys are not able to follow anything or have any doubt or want to me to explain anything again, just unmute yourself and interrupt in between because there is no chat, so I can't understand how flow is going. Is there any issue or problem you are having in understanding things? So that's why interrupt me at those particular points if you want to understand. So okay, already output came. I had not scrolled below. See, I had told you guys now that I will get soon error that you exceeded quota. Please check your plan. Showing pre-recorded trace instead. What happened? Gemini API key failed. Why it failed? Because a lot of keys were tools were getting call and a lot of Gemini means basically Gemini API key call was happening or API call was happening. You will see sudden jump. Like previously we had done 2 requests and currently there will be a high request count because we had recently called agentic one. So the graph will be kind of sudden jump sort of. You see the jump. Okay, this is hour wise, date wise. So you see from 2 we jumped directly to sort of 20 plus, and that's why the rate limiter got applied and we could not get the output properly. Now I will do that particular thing. What I will do, because either we create another API and then do it, or I can do the local LLM because we have that particular power, and that's why. So local LLM is important for multiple things. One being this is medical use case. So data should be kind of everyone is, there are various standards across the world regarding management of the medical data like HIPAA and other standards are there. And we, let's say that I am a hospital and I have developed this application. So then I don't want my patient's data to go to Google. So then we can have local LLMs hosted. And now again, I will run it before. Okay, let me first run it. It will keep on. We will see that we will have again because we are running local. So spike in GPU. Now leave that thing. We will go first above and we will understand few things. What? Okay. Let's say how we define a, well, let me explain one particular thing. Okay. Already happened, it seems. No, already happening. And the agent, see now agent call, you can see. Step one, check bed availability, total beds available. The agent is doing this. This is not anywhere hard coded. So that's why it is taking even time. If I will change the name Mira to, let's say, anyone, Nidhi introduced me. If I change it to Nidhi, the name will get replaced in the agent call with the patient data being this one. And agent calls are happening. So agent patient, bed ICU, region STMI with possible right low pneumonia, because now we have replaced it with this one. So it is properly identifying right low pneumonia, which if you see there is kind of in the right side visual some sort of abnormality. I am not medical professional, so not totally understanding how these things reports are read, but still I'm able to make sense of. Step 6, what happened? Alert message to doctors and cardiologists and ICU team to targeted team. It send the message to return to send true urgency normal and stuff like that. What is the agent's final response we get after execution? Final status, Mira got bit. So ICU bit assignment, physician approval is pending, STEMI, but Mira the system already assigned, system alert already sent, next step, await physical physician approval for bid assignment. This is human in the loop basically. Now how LLM calling happens, so this is kind of, you guys read it also. What is safety human in the loop? Just now you read safety human in the loop, like me waiting for pending physician approval for this with possible, no, yeah, if you see bed assignment, a must get approval for. If I had removed this particular part of the prompt, that human in the loop, it would have not asked for any particular thing related to a human in the loop basically. So what happened? The agent checked bed, looked up X-ray, searched guidelines. Guidelines we had already embedded in our articles. Where is it? Okay, our articles I had already. Yeah, these are the articles. The AI proposes, the physician approves, and many things like that happened. So you see the critical action, attending physician must approve bed assignment. If I had removed this particular part, the agent would have said that okay, bed allocated, and it would have changed the database status of that particular bed status, or final status we had about the bed availability. This one to the ICU 007 Mirati. I was saying about name change, right? So let me do condition, okay, severe community got. Let me do this, is that severity, let make it 1, and let's make it Nidhi STMI. I don't know cuff. Let's say I am not a medical professional, so I am not sure about other things. And let's leave this thing and let's see that what it does. Does it now call Arjun on this particular bed one? Because I have not changed the lab and vital, so I'm not sure. But instead of Nidhi, does it call Arjun? If this particular change happened, we will see now. I will again call it. Basically trying to see how the agent is able to make proper decision based on scenarios, based on conditions. Okay, I think I had hard coded somewhere else. That Mira should only be taken incoming emergency. Okay, this is scenario 1 and be ignored when loading from. Okay, wait. Let's see what it happens, because I might have already hard coded. This is kind of long, comprehensive 5 modules project. So if I had, okay, I think Nidhi got already. Let me search Mira, because if other places where apart from demo or hard coded one, Mira is there. So this is a demo run, not relevant for us. Scenario 1 incoming. Okay, here is the prompt. See, scenario 1 emergency admission, but I want to see other cases. Agent final call, I have handled the emergency. This is demo. So apart from that one, nowhere else Mira is mentioned. Scenario 1. So let's see that what happens. Agent call, total bets 8. Name Nidhi. Okay, Nidhi, it already taken Nidhi as coming. Instead of Mira, let's see whom it assigns bid. Okay, it is already considering Nidhi, because here in the scenario, Nidhi patient 001 female and other things was mentioned. Scenario, basically it was mentioned properly here. And in the call, basically apart from demo call also, here we are passing that particular information only, system instruction and everything. That's why perhaps it will call Nidhi only, not the Arjun, or perhaps the vital one. I will have to check to be sure. Assigned to bed. Reason success. See, this time it not for bed, it not asked for uh, permission from the other person. Why? Because it not considered that as a important urgent step to be asked for humans or human in the loop. So that's why it tool returned success. It changed the assigned to bed patient to true. And it, what are the conditions? So just like we had seen for the patient, it created this sort of data for it. So and assigned the bed to it. And yeah, these particular information, let's change the code to our original one where there was human in the loop as well. I think I have changed it. Let's go ahead now. We saw an impressive agentic solution basically, and many of you might have already heard about agentic solution, but at the same time have learned about a lot of frameworks. Like there are multiple frameworks to get these agentic capability built, like crew AI is there, then ADK is there, then uh, there are lang chain is also used for this particular purpose only. Auto GPT is used for this purpose only. So there are a lot of agentic. If I will just search agentic AI frameworks, tens of frameworks will come, which is used for this particular use case. But in our, let me show you which ones come. Yeah, Crew AI, AutoGen is from LangChain. I told. So this is LangGraph. LangGraph is by LangChain only. So if you see, ADK it has not mentioned. Okay, it has not considered ADK. ADK is also a agentic framework by Google. ADK Google say it will say agentic development kit, a modular framework for developing and deploying. So there are many frameworks, but in this case, we have not used any framework at all. This is completely based, simple, straightforward, but at the same time with lots of possibilities and tools which we have built. So path we are using just to take path of the parent path, which is in this case this sample chest AI. So if I will just show you the user path, that particular purpose only. Europathy. Okay. See, XPath, load X-ray image, and that's it. And there were minimum libraries getting used. Typing .env for loading environment variables, which is here. In this case, this we are using and stuff like that. So, and still we were able to achieve sort of remarkable performance or predict the condition of the patient that the patient should get which bed based on the condition and inform the hospital and many things like that. And that's why we called it frontier tech, that based on the latest tech. And do you know one interesting thing, that one model which I'm using currently, we will say, okay, in our output we would have seen at the top itself. Let me go without Gemini one. We are using two models. Okay. Okay, this one was the Gemini one. If you see MedGemma 1.5 plus Quen 3. Now, MedGemma, I already showed you. That's a medical model which is used for many, which can be used for many tasks like high dimensional medical imaging, CT, MRI, this, that, medical image classification. But tool calling, MedGemma was not good. I tried it, the tool calling, and MedGemma was not able to properly call tool. And the current model which I'm using, let me list Ollama list. That model is specifically not for Ollama list, and we are using this one specifically. Let me show you this on the Ollama, and this one is not for the tool calling. See, only vision task. This is for tool calling. This is not. Ollama is kind of a platform to host models. So various one, and each particular model has its tag that what is the purpose of this model. This is a recent model by NVIDIA, and tools calling one. See, Quen 3.5 is good for tools calling one, vision and stuff like that. But we wanted medical, so that's why we used this one for medical task, the MedGemma. I have updated it recently, so that's why 5 hours ago it is saying. And then we have Quen 3.5 Vision Model 4 billion one, which is for, okay, not Vision 1, Quen 3.5 here, this one. This is used for tool calling one, so that it can call tool properly, 9 billion one and stuff like that. Now, if anyone has a doubt in this one also, anywhere till now, you can ask, because this is kind of a main one. The main theme of our whole workshop of this particular day is this agentic framework or agentic tool calling and stuff like that. We have completely tuned it to medical use case. You have already seen a medical data set or anything. If you want to give me any sample use case that how can we do this, we can discuss it. Before we move on to bias and fairness, the fourth module basically. Any question or any feedback or any update by anyone? Anything you guys want to speak? Or any question till agentic one? Because currently there is revolution happening in the world of AI, and that is mostly because of agentic one. And what is the core of agent? Core of agent is LLM. So that's why we always talk about models and stuff like that. But now we are using the intelligence of the LLM to get things done. That's what agentic AI is. And that's why revolution is basically happening. Every other day, new frameworks are coming, new updates are coming. So even in this VS Code, if I will go to the chat section, you see the mode is agent mode. Ask mode is just chat mode, but agent mode is I can ask it to do anything and it will do all the code changes and stuff like that. Many of you might have heard about OpenClaw, or let's say that Perplexity computer, everything is agentic only, which is able to get your task done. So any question till now, either from this model side or stuff like that, before we move ahead to bias and fairness. Mm. So yeah, see, even these demos are of agentic capability. Like this one is navigator agent, because to host a particular
Hello, sir.
data. Yes, sir.
Sir,
Yes, ma'am.
sir,
Hmm.
sorry to disturb actually.
Hmm.
Actually, there were some issues in the chat, I guess. But now, I think if you can just click on Q&A,
Hmm.
that tab, I think there you will be able to see the questions, and I think the students also can communicate in that. Can
Okay.
you please check that one, if it is proper?
Just trying to check. I can't see the Q&A section, by the way.
Q&A, that is on the top actually, where you can take the control chat, that
It's
those
okay.
icons are
Screen is
there, na?
visible. It's
Ah, yes,
screen
screen is
visible.
visible. Screen is visible.
So I think Q&A is not available to me. Where is it? Like, can you tell me exactly?
Uh,
Because
no,
this is the
I'm not
current
able
window.
to see that, sir. It is not
Okay.
able to see that. Okay, no problem. So you please continue. I will see
Ah,
how it can be managed
one
that.
thing it can happen, if you have any WhatsApp group or anything of all the students or information, they can ask question there, and
Uh-huh.
then you can just forward me. I will just now open WhatsApp here
Oh,
as well, and that
okay,
way
okay.
we will have sort of
Yes, yes. Okay, okay, okay. Sorry, sorry.
that can also work out. So if any question
Yes.
anyone has, they can unmute and ask as well, or you can forward me on the WhatsApp, and I will take that question up
Uh-huh.
front.
Yes,
Because
yes. So yes, yes,
Mhm,
that will be better, sir, actually, because at the end maybe we can have 10, 15
mhm.
minutes for the question answer, and that time
Oh,
you can answer that. Yes, that
okay,
works.
got it.
Yes,
So
thank you.
uh, the reason I'm stressing on question answer for now is, or anytime in the last also, because this is kind of our main component of the our workshop. We from a start onwards, we have seen what is LLM, what is transformer model or transformer architecture to be true, how RAG works, how LLM locally works, a lot of optimization technique, prompt technique, context engineering, chain of thought, reasoning models, many things we have seen. But at the end, currently, what is the use of all those LLMs and everything? That is agentic. That is agentic means our task getting done without we doing any particular thing or anything. Basically, LLM or LLM being the brain of it, the agentic framework, our tool. In this case, we saw the functions. If you will see, there are many functions built for each particular task. Say this function is for search medical knowledge. So this is the retrieval. This is also tool. So based on the query, it will send. If we will see tool call, this particular agent would have called with particular query. Let's see what was the agent. Search medical knowledge. So search medical knowledge query STEMI treatment guidelines, and it got based on that it got the retrieval from our initial data. So every agent call, tool call, and things are happening, and these are autonomously. So that's why this particular part is a lot essential for you to understand. Every one of you or any one of you who has any doubt, just send the question, because once you understand the agentic flow currently in the market, then means what is happening in the core, then you can go to any framework like ADK, Crew AI, and you can build easily anything. So there are many things related to agent. If I will just write upfront from my knowledge, there is memory of the agent, there is persona of the agent. Memory are different types: short-term memory, short-term memory, long-term memory. So short-term memory will be like, in this case, patient's data. Like who was coming? Meena was coming, right? I forgot the name. Okay, I'm bad with names actually. Was our data okay? Yeah, Mira. Mira was coming. So Mira will be in the short-term memory. Long-term memory, the RAG pipeline and our vector DB, all the RAG pipeline is the reason why long-term memory eh, is getting fetched, because the RAG pipeline is getting used in it. And if you will see below two, okay, tools definition, these are tools are we are calling these tools above RAG pipeline. I think it was there. Medical knowledge base we are creating and stuff. So that's how the long-term memory gets personalized, like what role this should perform. Like we had already told it that radiologist based on the chest X-ray. See scenario. So incoming patient Mira, the informations we have given it, this one I should have actually dynamically fetched it instead of hard coding it from the above. That way we could, when we had changed it to Nidhi, automatically the scenario would have changed. So yeah, this is kind of a context one. And context system instruction is what? This is persona. What is it? You are a healthcare AI agent mapping ICU operations, right handling patient. So there will be never make final medical decision without flagging for physician approval, so that AI does not, let's say in a future we are looking towards that AI can operate machine also and integrated with medical device, but surgical operations it should not automatically and autonomously perform, right? And that's why we have system instruction like these and stuff like that, many things to be true. That's why agentic is kind of the ultimate tool which works everywhere. Whatever, most of the tools which AI related and AI related you listen, all are agentic because they are getting you something done. They are not just giving you textual output. Now after this we will go upon the next part, bias and fairness. So this comes under fair. So see, in world, whenever we train a particular model, LLM and everything, we train on the world data. And world has all sort of data, stereotypes, biases, and everything. So that's why we have to ensure that AI is built in such a way that we can detect bias, we can ensure fairness, and we can do that sort of things. So here the question is you see in the top it's written that can we trust our agent? So how for all demographic people it is properly fair or not, or bias or not? Does it meet fairness requirements like FDA, CD, SEO? These are requirements given by this, and this is a particular regulatory check framework which I have already used it. I will showcase you. So this is provide, yeah, see. So pip install SAP. Okay, this is setup requirement which we have installed already, but I will show you. This is the main kind of a model which we are using for detection of the fairness and bias. Now, this will be interesting one. Why? Because let me tell you one interesting story. What happened is that October, it was I think 2019, Science magazine published a paper like AI healthcare used by major hospitals to prioritize patient were systematically discriminating against black patients. This is USA report. That's why I'm quoting the Science magazine's one and stuff. And because the model was trained on a data set of in such a way that was already biased towards black patient because of possible history and whatever, and the model was also doing the same. The training data was biased. It used healthcare spending on all the training of the biased data, and what we got, a output which was biased towards the black ones. Now that's why the finally agentic which we have built till the third one, which is kind of our final solution. But before deploying this particular final solution, we have to ensure that we check that this is a fair sort of agentic framework and not biased towards anyone. Let's say we have already seen that ChatGPT is biased towards some reason and ethics, and people complain on the Twitter and all, and then the ChatGPT folks and stuff update the system prompt and everything, or retrain the model and stuff like that. Now let me do is that run our particular module 4. You will, okay, what is happening is that those particular models which I just now showed you and frameworks is getting initialized. This story only I was telling you. that in means this is a science article based story that in 2019 what happened is that it detected that US hospitals was found to systematically discriminate against black patient, denying them equal access across care. So first of all, before checking that our model is good or not and stuff like that, we will generate 2000 synthetic patient records with demographics like race, gender, age, insurance type, because let's say the model can be biased towards insurance also, that those who are covered under insurance might get priority in hospitalization. But if you think societally, that is bad, right? That okay, insurance is for the financial claim, but towards a biased for someone who might be less ill, getting preference than someone who might be more ill just because one has insurance might also be the one reason. So if you see, we have created here pairs, synthetic data of patient, 2000 records created, and then we do is that we train a model to detect bias. Now this is this we are doing a training of 100 trees. This is not LLM specific because we are doing a kind of traditional ML based training, we will see. And now then we do the bias detection based on the demographics and stuff. Let me show you the code wise. Okay, this is third one. So if you say just we are importing libraries and stuff here, this generate bias data set. This is so that's why if you are saying rand int is taking random choices for race also, gender also, age also, all these choices are random. Like out of male and female, there is now I have done already so random, but there is interesting thing. I have embedded bias in the training also, means data set creation itself. How you know? See, I have given the probability of male getting choice is 55% and female getting choice is 45% only. So when I will create the model will be 55% more towards selection of the male possibly and stuff like that. I have in the race also I have took 60% as the white people, black as 0.15, Hispanic as 0.15, Asian as point point 0.1 means basically probability of from 0 to 1, these are in that particular range. But if we will say in percentage, it will be 60% and stuff like that. So that's why if you will see P is what parameters, it will be the probabilities associated with each entry. This is the documentation of that particular one. Now, let's go to our model run. So you see, model got trained, overall accuracy of 59%. Looks okay, right? Huh? But here is the issue. Black patient. Now let's look deeper. Asians accuracy is 61%, count 62. This is also flagged. Black patient 54%. That's 7.2% is difference. 62 basically here and here 54, so 612, so approximately 7 plus 7.2 perhaps. Black patient difference, percentage point gap. Females, it selected accuracy as 56.2%, but male kind of 61%. Now another 5 point gap here, 5% gap from 56 to 61. So here also gap of 5.1%. We can see that there is a bias. Now I had kept the bias as that if below 5%, then we could have ignored it. But since this is beyond threshold, that's why we will look. Now bias reveal how the, so this was our data, means synthetically curated data on which we trained our model. And then for the model, we did sort of prediction. If I will show you, so train plus bias detection. So first we train a sort of gradient boosting classifier model for 100 epochs, 100 trees model, not 100 epochs, 100 trees model in the architecture one. Then we, for the same model, we did detection for based on the genders and everything, we got it. Now you remember this one we had imported on the top. If you see the what is the use of this one, exact matrix regulators check, that before, see, in the US and many countries, before any medical device gets approved, the authorities check for the bias in that particular medical device, means AI medical device output and stuff like that, or final suggestions getting given, or let's say LLM reference also. So that's why this fairness metrics helps one to detect bias. So if you see, provide 70 plus metric to quantify group and individual fairness in dataset and machine learning model, helping detect bias and detect and mitigate bias. Basically, it helps also. Key metrics include a statistical priority difference. We will be using these things definitely in our this one also. Now, three, okay, where is our output? Yeah, yeah. So regulatory, this one framework only I was talking about. These are the metrics by FDA, and this checks for AI medical device approval. So just now we saw that a statistical parity difference, it checks off. You see here also it had told now a statistical parity difference. So it checks the value of our is 0.0964. So our status is pass. But equal opportunity differences. We already saw that gender, sorry, race wise also there is difference, that black is getting less priority, and gender wise also there is difference. So equal opportunity difference there is. So it failed. Disparate impact, it failed. So if you see model catch is positive cases equally it failed. So these were two. Now we go to, so basically this is kind of what does SDP 0 means. SDP 0 means outcomes are equally distributed. EOD 0 means the model catches positive cases equally, and disparate impact, DI disparate impact means that below 0.8 is the legal threshold for discrimination. So our model failed two on these two. Now the explainability, what is the SAP explainability? So detecting bias is not enough. You detected bias. Doctors need to understand the AI's reasoning. Why the model detected bias in this particular data set for stuff, and why model said that, okay, means model, I mean to say this framework said that you have a bias in your one. So explainability need to be there. The AI flagged that this patient because of, okay, let me go where I'm saying about. So explainability, which patient I'm talking about? Say prediction 64. So patient number this. So I'm talking about this patient. So if you see the model, our model flagged patient number 1670. Why? This patient got flagged because the model was biased and 44% chances of admission was there. Prediction, medical adherence risk was there, and stuff like that. So based on these particular one, doctor can see and understand why this particular patient got flagged, or that this has high priority, or model is biased towards this particular patient because of the previous readmission and stuff data. This individual patient got flagged. Now we detected bias. We can explain individual predictions, like why this prediction happened. Features like medical adherence, it is in this range. Previous admission, race was black, so that's why he got rejected, and his percentage was, prediction was just 44%, not 50%. Gender was male, so that had positive bias, so risk is up. Means there is direct correlation that by being male he had high chances of readmission, by being black he, okay, actually low basically. So risk was high, so effect was direct correlation sort of. That's why we have read that previous admission was low, so that's why risk is high. Race was black, so that's why risk is high that he will get not get easily readmission, and insurance private, stuff like that. Now what we understood, so these are kind of key takeaways. We explained individual agent, individual person's predictions, but what else can go wrong? That we will look in module 5. So this is kind of, you can understand the key takeaways from our module 4, that bias sources in healthcare. Training data was biased, we already saw, because we created a biased data set. Biased data set on what basis? That we gave preference to a part of a particular race and stuff like that, and then created a prediction model which created different sort of biased outputs. Now here comes the final module, safety and guardrails. If you read it, every failure I'm about to show you happened at some major institution. What failures? We will see just now. With expert treatments and millions of dollars in funding, models got trained, but still that failure happened. Why? Because perhaps guardrails to stop those failures were not there. If they got it wrong, what makes us think that ahead also we don't need guardrails? We definitely need it. That's why we need systematic safety system, which can detect any sort of violations and then stop it. Now, let me run it and we will go through some of the use cases. One will be so as I said, there are many use cases which happened in the real world case. We will be going through some and I will explain you some. One I will be going through is IBM Watson one for oncology. There had, okay, the fifth module. Let's run it. Let's see from the top. For this also local, we are using local Ollama only. So module name is this. Every one of the failure happened at major institution. As I said, now real world failures I was talking about, IBM Watson. What happened? It recommended unsafe cancer treatments. So this IBM Watson was deployed in various hospitals at a major institution in US. And what happened is that it recommended unsafe cancer practices which were not even true to it, like denied care to black patient. Previously we talked about bias. In this case it already happened that see the below one, uh, l- Optum United Health racial bias which happened in 2019. So this was it denied to black ones, optimum one. Then we have epic sepsis model. What it does is that it had detected false positive rates. So high nurses started ignoring all high alerts because model was detecting it. And skincare cancer. See, skincare cancer one is the this one. What happened? Multiple skincare detection tool were trained and showcased impressive accuracy in detecting melan melanoma from skin images. But what happened wrong? The trained model was based on light skinned patients. So that's why there was an interesting video which I had seen once, that AI is not trained for many of the black people. Why? Because the training data set many times used in medical case is biased towards light skinned ones. See, light skinned patients. What happened? Accuracy dropped significantly for dark skinned. We know India has people of whole range from completely light skinned to completely dark skinned. We are kind of a plethora. Let's even I am brown in the somewhere in the mid range, and that's how the accuracy had dropped for those one reason, because diversity of data was not there in the training set. So we will see now the demo of live demo basically on guardrails of agent output. So testing safe agents output based on the patient's symptom, testing agents critical, forbidden agent use forbidden phrase, guarantees and stuff like that. So, okay, this is what I had done is that based on what particular cases, what should be our guardrail to not give output. So first thing is we are building a sort of AI agent, right? Which can even recommend people that, okay, this sort of approach you. So this sort of medical health recommendation or medicine you should take. And we had even seen that if, okay, let me do one thing. Open again the same in different, again in, wait. And I will show you how first one had even recommended sort of doctor prescription little bit. We will activate our virtual environment, which I am using in this case. Virtual environment activated. Let's run the first module. And I will show you, okay, this time also Ollama is working. let it present, and we will see that it had recommended some sort of one. But now what I have done, my model, is that if the output says that guaranteed, then we will reject the LLM's response, or it will say that 100% cure, because these are kind of LLM is claiming things which might not be accurate, and it should always add disclaimers in it. So requires approval, prediction medication should always require a physician sign off, because it's bad that till now when AI is not reached up to the claim that it can be held accountable for all the medicinal havoc it can create. That's why it should give require a physical approval and stuff like that. So safe agent output should have these unsafe agent output it detected, and it blocked it, like stop taking medication is one thing. Whatever medication you are taking from prior, it should not directly stop it. So these are kind of safety practices which I have added. System prompts matter. Why? Because LLM takes action based on the system prompt is kind of a precursor or persona based information which you are giving to it. So same model, same question, if you will give it a safe prompt, it will do is that properly give a output. So we have already seen what are the unsafe agent output, what are the safe versus system prompts which are we are adding. Now regulatory landscape 2026 one, India, I had already shown you one Sahi framework, but along with it, India has Ayushman Bharat sort of a scheme, Abha, which is EHR system. So Abha, many might you have already created Ava card. So DigiLocker has Ava card option to create. That is EHR system. That also has scope of regulatory scope for it to work. Sahi, I had just now shown you these are various frameworks. Worldwide, we had seen about one framework, FDA, which was used in fairness and by detection, also FDA based data, which we had seen. See, okay, FDA, yeah. These are what FDA actually checks. So FDA based framework, regulation framework, we are talking about India's AI update. This is it. Deployment index. So everything should be properly done. That explainability should be there. Now let's look at the demo part where our demo happened. Hmm. Demo was this one. Input was what? Based on the patient symptoms, this. Okay. Let me see. Patient seems fine. Recommend input. Unsafe patient, I have been the chest fit, what should I do? Okay, this is our output. Without chest pain can have many issues, differential red flag required. See, so when our system prompt tested based on the safe prompt, like safety integrated, when the same question was asked, one question was, I have been having chest pain for a week. What should I do? Output came like this. Chest pain can have many issues, this general. But with safety prompts, when we had included safety prompt, let me show you in code. We had two sort of scenario. Safe agent output, okay, not this. Safety prompt. So these are the checks which we are doing, based on which we are saying this, that checks passed, warning this, like that stuff. So these are cases. I'm searching for system prompts, which I healthcare guidelines. Okay, action that always require physician approval, validate. Okay, guardrails demo. Yeah, here. So here are the examples I have given, sort of what is safe prompt and stuff like that, not safe prompt. Here we are safe versus here. So safe versus unsafe demo. So in the unsafe demo one, what we do? Unsafe prompt. Answer this medical question directly and confidently. And we sent it. What it answered? It automatically started answering without any disclaimer and stuff like that. Because this one, you remember when we had done for the Gemini, Gemini had initially only said that I won't give you any medical advice. Let me do this one on the Google search, and you will see why guardrails are important, and even these are implemented in any solution across the world which is public. So you will see it will give disclaimer that I'm not a medical professional and stuff like that. Even after all the search, it will must see what it has given on the top. The information is for general knowledge and should not be taken as medical advice. Consult a healthcare provider for any medical concern, right? So without the guardrails in the back end of the Google, this would not have been given by the Google. So that's why guardrails are important. In our case also, unsafe prompt, what it did, it directly started answering it. Yeah. So chest pain can have many reasons, this, require urgent evaluation, panic disorder. It started answering. But in the safe prompt, what I have told, you are a medical AI assistant. You must follow these rules. What? Never provided definitive diagnosis, means 100% guaranteed, cured, no side effect. Always recommend consulting a healthcare professional, just like this one said, and even in the last, it might have said. Okay, want you to prepare. Okay, it has not said, it has initially only said it. So we always, even our prompt has provide general educational information only. Even if you see Google one has, this is for general knowledge only. And now then what was another one? Never recommend a specific medicine or doses, because kind of it is kind of a risky venture, right? We are first time creating it. And based on it, our output came. See the output after I will see the safe prompt. Okay, I understood your. So same question. I have been experiencing chest pain for a week. What should I do? Okay, I understood you are experiencing chest pain. It is important to take potential causes, red flags, next recommendation. Given the importance, it is crucial to consult a healthcare professional for they can access your symptom, medical history, this. It already told properly, right? That what can be potential causes, red stuff, and even gave recommendation that consult with other people. So yeah, so basically, as we discussed, 2026 India has a lot of frameworks, CDSO classifiers, AI. CDSO classifies AI diagnostic software as class C medical devices. So just like that, Sahi framework is there. Both platform benchmarking is there. Both I have not written here. Let me see. Both platform that is for benchmarking AI model using real world data while preserving patients privacy, because this is for medical use cases, so patient privacy is important. I already said there are many privacy related framework for health domain, like HIPAA was one thing. HIPAA, yeah, HIPAA compliance. See, this will be related to healthcare providers and business. So protected healthcare information, PHI, or privacy rules, security rules. So just like that, many frameworks are around the world which should be properly considered or given consideration. So that's why also these safety and guidelines should also be taken into priority. Now we have deployment readiness checklist, that we have model properly working. We already created multimodal, then RAG, then agent, bias and fairness. We checked it worked, then we created safety and guardrails so that we can stop whenever any flags up occur. And then we have finally checklist before we can deploy such a system, advice, edit, explainability, and stuff like that. And that's how our module 5 completes, which is regarding this particular one specifically, guardrails and safety. So let me take a step back from our whole presentation and tell you one thing that we built. We started from uh, workshop 1, where we saw that how transform architecture is there. We went and today we started with AI's multimodal capability and stuff like that. AI can see, memory remember, RAG, agentic framework, which we can say think, act, kind of tool act, check it basically for bias, fairness, and then protect it on the safety guidelines. And here's what it makes this particular works of 3, I will say, kind of a whole circular, that we have a complete production grade solution or framework, or we can say the a kind of picture in mind how we should approach a project, starting from, let's say, any use case where you might have idea regarding anything. There are many AI based companies in India also, like Cure AI is there. One, I know one guy who is specifically working in AI sector, who is a founder. So there are many such solutions like that on AI specific. Now we have 9 minutes left. You, any of you who have any questions, send to WhatsApp to ma'am, or you can ask, unmute yourself and ask any technological question, this medical solution, previous workshop, or anything. Now I'm open to question. Thanks.
Excuse me, sir.
Mm-hmm. Yes,
What are
Janani.
the job what are the job opportunities available in the field of AI related to biomedical engineering in India?
Mm-hmm. So see, first thing, great question that since for anyone who is associated along with this particular part, on the LLM side and stuff, how medical sector it is related with, right? So if you think that you have a specific skill, I just mentioned one startup called Cure AI, right? Think Cure.ai. Yeah. So just by going on the career, we will understood that there are a lot of jobs which are specifically designed. If you think in our project, specifically designed for testing bias also, fairness also, then testing accuracy also. How Gemma, let's say that we were talking about mid Gemma, right? How Google would have understood that which is it properly giving output response and not, or what like that. There would have been multiple people. If I will go to the people, means those who have developed it, who might be from biomedical domain, along with domain in this one, basically LLM domain, so that they can fuse both and can detect the bias in the model, can detect it that okay, this model was correctly giving outputs and or not. So specifically, see, I know AI job roles like currently Gen AI developer is a lot common. Then agentic AI developers are coming. AI engineer is one job which is AI. I will show you how this merges with the biomedical domain. And possibly I will try that a student resource guide will I will also try to share with a specifically mentioned career roles based on my research. So AI engineer is one which is related to this one. Then we have RAG engineer, and prompt engineer is kind of old one. That is the first one which started after GenAI arrived basically. Now its name is slowly changing to context engineer. If you think all of these roles will be relevant for biomedical domains also. Why? Because current the application will be specific to biomedical domain. The model, do you know why? Even though I was talking about one thing, that when I had one model, say in the model list, we had Quen 3. This is multimodal. This supports vision capabilities also, but still, and I had other vision models as well, but still I used MedGemma. Why? Because this was specifically trained for medical. So even for the model hosting of understanding of these particular model context, let me show you MedGemma, and there are many solutions they have created, demos. If you will see now, let me show you one demo. If you will see this sort of demo, only a person who is specific to biomedical domain along with LLM can create. Why? Because see, EHR related information is required. What is EHR? Electronic health record related information. Let me show you other demo built around this MedGemma. Say CXR Foundation model demo, usage of CXR Foundation embedding, radiology explainer. Just now I showcased this sort of scenario, right? Although this is different one, not exactly like ours, but similar sort of radiology explainer, appointment ready demo. If you see that one, this prepares patient and doctor for to be appointment ready, a doctor to be appointment. So there are all solutions might have required multiple health professionals, and I can easily guess that those who would have created it, that I can go on any particular demo, and if I could find anyone that who have created, okay, not here, I won't find it. This was related to demo. But if okay, this is also related to demo. If I can find any particular person who has worked on this, there is very high chance that that person will be associated with both domain. Okay, and we can do simple also search also, like Cure AI carriers I was saying. Now let's go ahead and see the carriers, explore there must be medical biomedical related job roles. Okay, LLM engineer, healthcare AI company, if you will see, so that might have already said that production grade. Okay, that build Q4 clinical facing assistant related to diagnostic flow. And you can ask me computer science, solid understanding. Okay, let's see where biomedical is mentioned or not in this case. See, experience in healthcare industry with an understanding of compliance and security requirement. Experience building. So you just saw that I just opened the first role related to AI on the Cure AI, and what came automatically came, right? The LLM engineer with experience in medical domain also. See, director. Okay, AI. Let me search here. Domain AI product manager. This will also have somewhat related to AI skill set. And we can even search many companies like this, that startups related to Gen AI medical domain India. I will search, I will go to the carriers and I will find many roles which might be convergence of also. See, it already searched. Now I will tell it to do research on job roles which are kind of in the kind of you need skill set of biomedical health and Gen AI. And I will just now say job roles on these these companies. Let me search. And you will see many such job roles will come in front of me, and you will then understood that okay, what are the careers specific to your one. Say clinical AI scientist, AI research scientist, AI engineer, now founded Bosman Labs, one RX AI, AstraZeneca, skill set proficiency in along with SNOMED, this responsibility building RAG pipeline, evidence from PubMed. If you see biomedical information data curation scientist, why this SMA is what? Subject matter expert. So if you are from biomedical domain, you can be a subject matter medical expert, and you can curate synthetic data. So data curation scientist you can be. So there is a framework by Google, Cynthia, I think. Data generation. Synthetic. Yeah, I'm searching for. Well, I forgot its name. I forgot its name clearly. I think Cynthia refers to different technology multi. I think this one perhaps Google synthetic data generation. Let me search which ones come. BigQuery, we are not interested. For medical, there is a specific. I'm not able to search now, but I will try to synthetic data generation, synthetic data allows. I will try to search and send in the student resource if I will search. But you understood basically, right? That there are so many LKI product manager. If you see biomedical, I can search even for bachelor level. Let's say bachelor level. And you will find many roles which will have AI, machine learning along with biomedical domain, biomedical computer science and related field. Okay, junior AML engineer. These are the healthcare startups which we can target and stuff like that. I hope you understood, Janani. Any other question, anyone?
Thank you, sir.
Welcome. Any question you have from workshop 1 till now, any code example you need to understand or anything, complete free hand on question asking. Or you can text to ma'am any question you have on the textual, or you can even let us send me question. I will try to send a proper answer to the same question by either creating a document for all questions or directly sending answer to the ma'am. Okay, then thank you everyone for being part of this workshop series. Third one, this was from seeing AI, creating AI, building autonomous agent. We have understood kind of full stack. I will tell you, just don't read things or watch lectures. Go build something, build real world project, and that way you will understand a lot. And one thing you should remember is that building AI that works is really, really hard. But experimenting with it has came to such a scale that you can see so accurate outputs coming. And future going ahead, these fields are going to scale a lot faster. Even the mid Gemma I was talking about, this is so recent model that it's amazing the speed at which the world is progressing, specifically in Gen AI domain. Thank you, everyone. Thanks, ma'am. Hand over to you.
Um, so yeah, we come to the end of this session, and over these sessions, we all are glad that we have learned and gained insights that will surely help us in our academic and professional journey. So I really hope this workshop has added value to all of your knowledge and inspired you to keep learning and growing. So I would like to thank Mr. Bhaskar for sharing his time and expertise with us. Thank you so much for this wonderful workshop today. It really helped us a lot. I will also extend my gratitude to Professor Geeta Narayanan ma'am and Professor Suvarna Udgire ma'am, our conveners, and our HOD Dr. Gajanan Nakre sir for this continuous support. Well, thank you to all the participants for joining this session. Have a wonderful day ahead. Thank you. Thank you once again, sir, for this workshop.
Thanks. Thanks, everyone. Looking for any questions you have or any feedback you want to give, just text to ma'am. I will get from the same from ma'am. Thanks, everyone.
Sure, sir. Thank you.